Functions play a central role in calculus and, of course, the applications of calculus. Many scientific laws and engineering principles describe how one quantity depends on another. And so in 1673, Gottfried Wilhelm Leibniz coined the term function to indicate the dependence of one quantity on another. So there is one quantity depending on another quantity. So this dependence is described in the definition of a function. So by definition, if a variable y depends on a variable x in such a way that each value of x determines only exactly one value of y, then we can say that y is a function of x. Let me repeat that. If a variable y depends on a variable x in such a way that each value of x determines exactly one value of y, then we can say that y is a function of x. Meaning if there is one value of x and there are two values of y, then that is not a function. So there has to be exactly one value of y. And so we can also define a function to be a relation in which no two ordered pairs, because there's only one 1:1 correspondence for x and y, then we can say that a function is a relation in which no two ordered pairs have the same first component. So a function is a rule that associates a unique output with each input. So in this case, x is our input, y is our output, and this should be unique. So if the input is denoted by x, our output is y, and this as a whole is our output, this is read as f of x. And this entire equation, we read this as y is equal to f of x, or meaning y is a function of x. So x is our input, our independent variable, y is our output, which is our dependent variable. So meaning the value of y here depends upon the value of x. So to evaluate functions or to find the value of functions, we are simply to input values of x to the given function to find the corresponding value of y. So for example, if we are given the function f of x equals x squared minus 2x plus 4, and if we are to find f of 2, we are simply going to substitute this, because this value here enclosed in the parenthesis is x, then we are going to substitute that to the x's in the given function. So this is equal to 2 squared minus 2 times 2 plus 4. This is 4 minus 4 plus 4. That's cancelled. So therefore, f of 2 is equal to 4. If we're looking for f of negative 1, the value of x this time is negative 1. We're going to substitute that. So negative 1 quantity squared minus 2 times negative 1 plus 4. So this is positive 1 plus 2 plus 4. That is equal to 7. So f of negative 1 is equal to 7. Another example, if we're finding f of 3h, the value of our x this time is 3h. So we have to substitute this entire thing here. So 3h quantity squared minus 2 times 3h plus 4. Raising 3h to the power of 2, we get 9h squared minus 6h plus 4. And so we have a trinomial, and we do not have any similar terms that we can combine, so that would be our final answer. Another example, we are looking for f of x plus h. This time, our x, our input, the term here inside the parenthesis, our input, and we are going to substitute that to the x here. So this would now be equal to x plus h quantity squared minus 2 times x plus h plus 4. So raising x plus h to the power of 2, we get x squared plus 2hx plus h squared, and then multiplying is minus 2x minus 2h plus 4. And then we try to see if we can combine any similar terms. So there is none. So therefore, that would be our f of x plus h. Okay, number 5, if we are to find f of x plus h minus f of x all over h, we are simply going to perform this operation. And so we copy the fraction bar, substitute f of x plus h, but we have solved for this in the previous number, so we're simply going to copy that. So x squared plus 2hx plus h squared minus 2x minus 2h plus 4 minus the value, or our f of x is just this given right here, so we're simply going to copy that also, x squared minus 2x plus 4 all over h. So let's try to remove the parenthesis here. So let's x squared plus 2hx plus h squared minus 2x minus 2h plus 4 minus x squared. This would now be plus because that's a minus and a minus. So plus 2x minus 4 all over h. And then we find terms that we can cancel. So we have x squared here and negative x squared here. So we can cancel that. And then we have negative 2x and a positive 2x here. So we can cancel that also. And then we have positive 4 and a negative 4 here. So we can cancel that also. So what's left in the numerator is 2hx plus h squared minus 2h all over h. 2hx plus h squared minus 2h. And then as you can see, there's a common factor here, which is h, so we can factor that out. So factoring h, we have 2x plus h minus 2 all over h. And so we can now cancel h. So our value, the value that we're looking for is 2x plus h minus